Good evening, Stella. Hope you're doing well. Last time we saw mm, we had an introduction to integration. We went into the vocabulary where we saw what's basically termed integration. So today we are going to see what's the difference between a definite and an indefinite integral. So without wasting time, let's get into the stuff. So wait, let me drag this. So basically, last time I gave you some basic definitions. I think it was in the introduction. I said whenever an integral is not having boundaries of integration, we term it an indefinite integral. Whereas when an integral is having boundaries of integration, we qualify it or we term it a definite integral. So that's a basic definition you can give to any 2-year-old or to any child. You understand? Now let's see if I will say a mathematical way of defining it. So let, for example, f of x be a function defined on an interval, let's say I, defined on an interval I. The indefinite integral, the indefinite integral of f of x denoted by the integral of f of x dx. I add dx here because the variable is what? The function is defined in terms of which variable? Dx. If it was f of t, I would say dt. You understand? So the indefinite integral of f of x denoted by the integral, this is the integral sign, integral of f of x dx is given by, let me take the right pen. The integral of f of x dx is simply equals to what? Capital F of x plus a constant of integration, where this k belongs to what? The set of real numbers. This k can be to any real number. You know what is termed the set of real number. So any real number here will satisfy this. So this is what we call an indefinite integral. An indefinite integral. So you see clearly that it's not having boundaries. You understand? So this capital F of x is a primitive. It's called a primitive of f of x on I, on the interval I, on which the interval I on which f of x is defined. And we said k is a real number, and f of x plus k is the set of all primitives, is the set of all primitives of f of x on I. You understand? So let me try to explain things clearly by taking a small example. Let me wipe this, write it back, and wipe this. Okay, let's take for example, and I said indefinite integrals are also called what? Primitives. Remember that they are called primitives. So let's take for example, you are given f of x equals to, don't bother, we're going to see all these properties on how to integrate functions in the next coming videos. Let's say for example, I'll take a very simple example that I'm sure you know how to integrate. Let's take for example, you are asked to integrate, let's say x squared. You understand? Somebody can have, you are asked to find a primitive of this or an indefinite integral of this f of x. You understand? The integral of f of x dx will be equals to what? How do you integrate this? You have x 2 plus 1 all over what? 2 plus 1 plus what? A constant k1. You understand? So this implies the primitive of f of x dx will be equals to what? x cubed on 3 plus the constant, let's say k1, where k1 belongs to the set of real number. Let me take a small, let me do something here for you to understand things clearly. If somebody integrates this and writes, for example, that the integral of f of x dx is equals to x cubed on 3 plus 2, and you found that the integral of f of x dx is instead equals to x cubed plus 3 plus 5. These two primitives, they are all primitives of this. They are all primitives of this. Because if you differentiate this and differentiate this, you will still have this x squared. You will still have this x squared. You understand? So that's why whenever you have asked to find a primitive of a function, that's why you will always see at this end a constant of integration. This is simply to say that in fact, ceci nous permet juste de dire que, n'est-ce pas, ceci nous permet juste de donner l'ensemble des primitives de la fonction quoi, f of x equals to x squared. Tu vois un peu, ça nous permet de donner l'ensemble des primitives. Parce que quelqu'un peut bien dire que lui, sa primitive, ici là, c'est quoi? X cube sur 3 plus 2. Tu vois un peu, x cube on 3 plus 2. L'autre peut dire que sa primitive, c'est x cube on 3 plus 5. Donc, pour éviter tout ceci, c'est pour ça qu'on met plutôt à la fin ici. Tu as vu qu'à la fin du primitif ici, là, on a mis quoi? A constant of integration. Donc, it's very important. Donc, quand on te dit de faire un primitif, ne fais jamais l'erreur de donner la réponse sans mettre un constant of integration. Si tu ne mets pas le constant of integration, ta réponse est fausse. Ta réponse est simplement fausse. Tu vois un peu, ta réponse sera fausse. Donc, il faut toujours, always remember to add a constant of integration whenever you are asked, whenever you are in a situation where you are finding indefinite integrals, that is, integrals where boundaries aren't given. You will also notice that an indefinite integral is always a function of the variable, of the starting variable. Ça veut dire quoi? Si tu remarques bien, le primitif qu'on a trouvé ici là, tu vois x cube on 3 plus 2. Tu vois bien que it's a function of quoi? It's a function of x. Donc, ce que tu dois retenir, c'est quoi? La première, la définition d'indefinite integral. Et tu dois aussi te rappeler que an indefinite integral will always depend on the variable on which, on the starting variable, if I will say it like that. Tu comprends un peu? Donc, c'est un peu ça. On va voir maintenant ce qu'on appelle definite integrals. Attends un peu, je vais prendre le stylo. On va voir maintenant ce qu'on appelle definite integrals. Bon, ça c'est B. Definite integrals. J'ai dit dernièrement que I said last time that whenever we add boundaries to an integral, it is simply termed a definite integral. So that's a simple definition for a definite integral. So let's try to define it in a mathematical way. Okay, let f of x be a function defined and continuous on I. Let f of x be a function defined and continuous on I. And IC, this I is an interval. It's an interval. And A and B be two elements of I. The two elements of I. Okay. The integral the integral denoted by the integral from a to b of f of x dx is called a definite integral. Is called a definite integral, and it is given by je prends le stylo rouge. The integral from a to b of f of x dx is simply equals to you first find a primitive of f of x. Let's say that primitive is capital F of x, and you add the boundaries from a to b. It can also be denoted as capital F of x from a to b, which is simply equals to f of b minus f of a. Voilà, tout simplement. That's simply what is termed a definite integral. Okay, essayons de proof. Let's prove how this f of b minus f of a comes out. Okay. Donc, proof. On doit prouver que le integral from a to b of f of x dx is simply equals to capital F of b minus f of a. Ok. On sait que le intégral, déjà, essayons d'abord de calculer le primitif de f of x dx. Tu vois un peu. On sait que, si tu te rappelles bien dans la vidéo précédente, on sait que le primitif of f of x dx, c'est simplement égal à quoi? F of x plus le constant k. Donc, je reviens ici, là. Je vais revenir ici. Ceci est tout simplement égal à quoi? On est ici, là, recall. On sait que le intégral de f of f dx est tout simplement égal à quoi? Capital F of x plus le constant k, where k belongs to quoi? The set of real numbers. Mais, on sait que quoi? Le intégral from a to b of f of x dx, on sait que c'est égal à quoi? On va remplacer ceci. Ça fait f of x plus le constant k with boundaries going from what? A to b. Tu vois un peu. Ce qui sera tout simplement égal à quoi? Je remplace d'abord le upper boundary. Ça va me faire f of b plus le constant k. Ici là, where I see x, I replace by what? B. Donc, ça me fait f of b. Ici là, il n'y a pas de x. Donc, ça sera tout simplement k. Minus quoi? F of a, capital F of a plus k. Tu vois très clairement que les k vont partir et on reste avec quoi? F of b minus f of a. Donc, il faut savoir que lorsqu'on te dit lorsque tu te retrouves dans un exercice où tu dois chercher un definite integral, c'est-à-dire un intégral où on t'a donné les boundaries, la première des choses, tu finds d'abord quoi? Le primitif. Tu as vu, j'ai fait ça ici. Tu finds d'abord le primitif. Dès que tu trouves le primitif, tu vois un peu, dès que tu trouves le primitif, tu fais simplement quoi? Tu fais simplement f of the upper bound minus f of the lower bound. Tu vois un peu ce que je suis en train de dire. Donc, c'est un peu ça. C'est un peu ça. So, that was basically what you needed to know in terms of this b is called the upper bound. The upper bound or upper limit. And a is termed the lower bound or lower limit. Tu vois un peu. Donc, so that's basically what you need to know in terms of definite and indefinite integrals. As I said, an indefinite integral, also called primitive, is whenever you are asked to find an integral without giving boundaries. And whereas, whenever boundaries are given, you are in a situation where you are finding what? A definite integral. So let's take ourselves in the next video where we are going to see some basic algebraic rules in calculating integrals. See you in the next video.